Okay guys, sometimes you might find that you have a shape where there is no right angle triangle in it. Okay, so for example, let's look at this one. This is an equilateral triangle. Okay, remember equilateral means that all the sides are equal. So we'll say that this side is 8 centimeters. This side is 8 centimeters. And this side is 8 centimeters. Okay, this is an equilateral triangle. Okay, now, if I said to you, I want to know the area of this triangle, well, that's a little bit difficult because you only know the sides. You don't know the height. Remember, the area of a triangle is half times base times height. Okay, we know the base. The base is 8 centimeters, but we don't know the height. Okay, now this is where we need to draw what we call an auxiliary line. Okay, auxiliary just means help. You don't really need to use the term auxiliary. I'm not too worried about you guys learning that. Okay, but when we're talking about drawing an auxiliary line, it just means that sometimes you need to add an extra line to turn things into a right angle triangle. Okay, so you need to look for ways you can make a right angle triangle. In this case, what we're going to do is we're going to add a line down here. Okay, I'm a little bit unsure of why that bit didn't go in straight. There we go. Okay, so we've added a line down here. And now you can see that we have two right angle triangles like this. Okay, so we have two right angle triangles here. And so now we can actually calculate the height of this triangle in order to then do the area. Okay, so we're going to call this H. Okay, now with this, you can see then that this side along here is going to be half of what the base is. So this is going to be 4 centimeters. All right. So now we can say that the height is one of the shorter sides. Okay. So we know that normally our formula is a squared plus b squared equals c squared. Okay. In this case, a can be h. So we know that we have h squared plus b is 4 centimeters. So 4 squared is equal to c squared. That's our 8. Okay, and don't forget that the hypotenuse is always the longest side. So that c should always be bigger than a and b. All right, so we have h squared plus 16 is equal to 64. Our next step is that we need to minus 16 from both sides. Okay, so we're going to have h squared is equal to 64 minus 16, which is 48. Okay, and therefore, when we take the square root of both sides, we get h equals the square root of 48. And again, we can leave it like this for using in our formula. And we should leave it like this because if we change it to a decimal and we round the answer now, then that means our final answer won't be as accurate. Okay, so if we round this now, if we find the answer now, sorry, my cat is playing with something. If we round this now to a decimal, then we're actually changing the accuracy of our final answer. So we're just going to leave it like this. Okay, so now to calculate the area, we can say the area is half times the base, which we know the base of the whole triangle was 8 centimeters, times the height. Okay, and the height was root 48. Okay, so our area is equal to half of 8, so 4 root 48. Okay, and at this point, it depends on whether we ask you to give the answer in exact form or or to round to a certain number of decimal places as to what you do here. If we asked you to do it in exact form, then that means that you need to simplify this square root. So we're going to do this as well, just to make sure you guys remember how to do it for the practice. Okay, so 4 times. Now remember, when we simplify square roots, you need to think of how we can divide 48 so that we can simplify it. So what number can be divided? What number can 48 be divided by? Okay, and in this case, I think the best option that we're going to have is 16 times 3, because remember, one of those numbers must be a square number from our square list, and 16 is on our square list. Okay, so 16 times 3 is 48. Okay, so we have 4 times root 16 times root 3. Okay, root 16 we know is 4, so it's 4 times 4 root 3, which is equal to 16 root 3. Okay, so this is the simplified form. Okay, you guys have done this in the last unit, and if we wanted to convert this to a decimal, I'll take my fancy calculator. It will just take a second. Okay, we have 16 root 3, and if we want to turn that into a decimal, we get 27.71. So it's approximately equal to 27.71 centimeters squared. Remember, with area, it's always going to be squared, unless we're talking hectares, but that's a different story. Okay, now this was a simple one. This is just a equilateral triangle. You can also have an isosceles triangle, and remember, we do expect you to remember this. So equilateral meant that all sides were equal. Okay, isosceles, an isosceles triangle was two sides are equal. Okay, so you can use this technique for either of these two types of triangles. Okay, for a scalene triangle, you can't actually do this. Okay, that's when all three sides are different. This can also be used for things like trapezium. Okay, so we can also go, sorry, I want to do this one. So we can do it for a shape like this. Okay, and if you know that, for example, let's say that this side is 5 centimeters, this side is 3 centimeters, and this side is, I don't know, 7 centimeters. Okay, if I asked you to find the height of this, the area of this shape. Okay, so again, we start with that auxiliary line. Okay, and in this case, it's going to come down here. Okay, we now have a right angle triangle. We know that this part here is just going to be 7 minus 3. Okay, so we have 4 centimeters here. We know our height is 5 centimeters. And in this case, we don't even need to use Pythagoras, okay, because we don't actually need to know this sloped side. However, that's to find the area. So our area is just going to be 5 times 3 plus half by 4 by 5. Okay, you guys have done this back in Unit 2. Okay, so we have 15 plus half of 20. So you have 15 plus 10, which is equal to 25 centimeters squared. But if I asked you to find the perimeter, okay, remember the perimeter means the distance around the shape, then that means we actually need to know this length here. Okay, so to find the perimeter, we need to know this length here. We know all the other lengths, we just don't know that one. We can calculate this perimeter using Pythagoras. Okay, so we'll call that C. All right, so we know that A squared plus B squared is equal to C squared. A is 5, so 5 squared plus B is 4. 4 squared equals C squared. Okay, so we have 25 plus 16 equals C squared. Okay, 25 plus 16 is 41, so C squared is equal to 41. C equals root 41. Okay, and again, I like to always round this at the end after I'm finished. Okay, so we're going to say therefore the perimeter is equal to 5 plus 3 plus 7 plus root 41. And if we calculate that, let's use my fancy calculator. This is the calculator that you guys will get when you start year 4. Okay, so this is the calculator you guys will need in year 4. So we have 5 plus 3 plus 7 plus root 41 equals, and if we turn it into a decimal, we get 21.40. So the perimeter is approximately equal to 21.40 centimeters. Okay, so this is using an auxiliary line, or a line that will help you. Okay. The main tip I have for you with this is really just try to look for ways you can make right angle triangles. Okay, that's the big thing. Just try to find right angle triangles, make them, calculate some distances, and see if it works out.